multicast IPv6 address. Because of that, this is the first multicast address that we have on the router 1. You know that here we have the router 2, but because I didn't configure the IPv6 unicast routing on this router, this means that this is not routing the IPv6 packets. Because of that FF02:2 does not enable on the interface of the router 2. And also, you know that on all of the interfaces that have enabled for IPv6, okay, we have another IPv6 address, another multicast IPv6 address, FF02:1. For example, on the PC2, okay, and also on the, for example, PC1, okay, interface, and also on this router, and also on the gateway, the FF02:1, okay, is the all IPv6 host multicast address. This means that on all of the interfaces that is enabled for IPv6, we have this multicast address. Don't mistake that this is not the unicast IP address. This is a multicast IPv6 address. And you know that we cannot use the multicast IPv6 address, okay, for the source IPv6 address in our packet. In the source IP, okay, or source IPv6, every time we are using the unicast IPv6 address, but for the destination IPv6 address, we can use the unicast and also the multicast. Okay, you know that in IPv6 we don't have broadcast. After that, as you can see here, when we are sending the RS, the destination IP of the RS is the FF02:2. Why we should send the RS or router solicitation to FF02:2? Because the PC1 know that the router or the gateway of this network has this IPv6 address, and if the PC1 send the RS or router solicitation message to the FF02:2, the default gateway or default gateways of these networks should take this, for example, should receive this RS message. The source IP of the PC1 is the LLA address of the, for example, interface or network interface card of the PC1, and you know that the PC1 can generate easily this LLA address with the help of the EUI64 method or random method. Because of that, the PC1 has LLA unicast address, okay, IPv6 address. It can send the RS to the FF02:2. Then the router 1, after receiving the FF02, the RS into the destination of FF02:2, because on the interface of router 1 we have this IP address, should answer with the RA message, the next message. RA is the abbreviation of the router advertisement. And the RA's destination IPv6 address is FF02:1. And you know that this destination IPv6 address is the multicast address for all IPv6 hosts. This means that PC1, PC2, and this router, okay, can take this RA. Included in the RA, we have the prefix of this network. For example, the interface of R1, the ETH00, has the 2001 DB811:1/64 as its IP address. And here we can see the prefix. In the prefix, we don't have the interface ID. In the prefix, we have only the subnet ID. 2001 DB811:64. 2001 DB811:64 is the subnet ID of this IPv6 address. When the PC1 is receiving the RA, because the destination IPv6 address of the RA is the all IPv6 host multicast IPv6 address, okay, the PC1 could generate its IPv6 address with the help of EUI64 or random method. I will show you. Okay, why? Because you have the prefix, you can add the prefix to create the, for example, EUI64 to create the interface ID. Look at here. Now PC1 has the prefix. The prefix is 2001 DB811:64. We can use the EUI64 method, or maybe in some other operating systems we are using the random method 2001 DB8 then :1:1:/64 plus random method, okay, and finally we will have our IPv6 address. This is the IPv6 address, but you know that we need the default gateway. The source IP address, okay, of the RA is the link local address of the interface of router. Because of that, actually all of the devices such as the PC1 can use the source IP address of the RA source IPv6 address as their default gateway. RA source IPv6 address is the default gateway or default router of the in devices inside this network. So easy. I will show you how it is working. For configuration of the stateless address auto configuration, first we need to configure the router with the IPv6 unicast routing. After that, we will have this IPv6 address, for example, we will assign one IPv6 address to the interface of router, and after that, router automatically can send the RA. When the PC1 is enabling, the PC1 should send its RS, and after that, the router can send the RA, and after that, you will have the IPv6 address on the PC1. Don't forget that the RA should be sent in some intervals. For example, by default in the router, in the router 1, okay, the RA's interval is 200 seconds, but if you want, you can change it. Okay, let me to show you one simple scenario first for understanding this part of the stateless address auto configuration. After that, I'm going to talk about the configuring the stateless address auto configuration for example, assigning IPv6 address to the interface of router 2 ETH00 as a client, not as a router. You know that this is a client until we configure the IPv6 unicast routing. Let me to first understand the first part of scenario. After that, we can talk about the router as the client of the stateless address auto configuration. In this simple scenario, I am going to talk about the IPv6 address assignment with the stateless address auto configuration. Here, as you can see, we have router 1. Here, we don't have any configuration. We should configure anything from the scratch. First, starting from the router 1, enconft, okay? And then host name, or for example, R1. This is the router 1 interface ETH00. I am going to assign IPv6 address 2001 DB8 11:1/64, and then no shutdown. Okay, until we didn't configure the IPv6 unicast routing on the router 1, we will not have any RA or the for example, router advertisement. Let me first show you. Look at here in the show IPv6 interface ETH00. You can see that here we don't have any information about the RA. I will show you when you are enabling the unicast routing. Here we will have information about the RA. Also, as you can see here, only we have one IPv6 multicast address. These two related to the IPv6 solicited node multicast address. This is not related to our topic, but here, as you can see, we have only FF02:1 because the ETH00 is only one IPv6 enabled interface or host. This is not the interface of router now, but after configuring the IPv6 unicast routing, okay, now you will see the change. Show IPv6 interface ETH00 can show us now we have two multicast IPv6 address here, and as you can see here, the first is for the all IPv6 node host, and the second is for all IPv6 routers FF02:2. And also here you can see ND router advertisement. ND is the abbreviation of the NDP. NDP router advertisement are sent every 200 seconds, as you can see. Because of that, we can easily understand that on this interface under for example router 1, now we are sending the RA in each 200 seconds. If you want, you can capture the RAs. For example, let me to show you. I'm going to capture the ETH00 interface with the Wireshark. You can easily do all of these tasks because you need to see the details. Okay, if you don't understand the detail in troubleshooting in configuration, you will have many problems. Look at here. First, let me to find the RA message. RA message is one type of ICMPv6 message in the for example TCP/IP packets, because you know that we are using the ICMP message, different type of ICMPv6 message for sending different information in the IPv6, such as the RS, RA, NS, NA, and some other things. I will show you. We need to wait some second because you know that each RA message will be sent in the intervals of the, for example, 200 seconds. As you can see here, we have many IPv6 message, but all of them are neighbor solicitation. I'm waiting for finding one RA or router advertisement. You know that each 200 seconds, one